Alright, I'm sorry that we got cut short. The screen capture program I use is calibrated to 10 minutes. Anyway, hopefully that gave you a little time to digest what happened. So anyway, we got to this point, right? So all I'm going to do now is I'm just going to get rid of the Qt color coding and simplify things. So on the left, there's nothing really to simplify. I just have 1 plus 2 plus 3, blah, 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 all the way up to plus k plus 1. And on the right, there's nothing really to simplify here, but notice, k plus 1, I just simplified to k plus 2. On equation 2, I do some of the similar simplification. There's nothing really to simplify on the left, but on the right, notice that I can simplify the denominator to k plus 2. Okay. So, again, just to review, I just need you to understand that these are generic steps. Generically speaking, what did I do? I took my equation and I replaced n with k. Okay. Then what did I do after that? After I replace n with k, I take it to the next step. So instead of adding up the first k terms, okay, I add in the next term, the k plus 1 term. Okay, so on the left-hand side, I add the next step, and on the right-hand side, I simply replace k with k plus 1. So now that my right-hand side is calibrated to calculate not the first k terms, but the first k plus 1 terms. Okay, so those are your generic steps. Generically, that's what you do. In practice, I end up with these two equations. Now, notice that I wanted to assume that my equation was true up to some step k. Notice that I assumed that this is true. I haven't actually used that assumption yet. I'm just writing equations. How do I actually use this assumption? Well, notice. Does this highlighted part look familiar from our assumption? According to my assumption, if I add up 1 plus 2 plus 3, yada yada yada, all the way up to plus k, according to my assumption, this whole highlighted part is actually just equal to this. K times k plus 1 divided by 2. So how am I going to use that assumption? Well, I'm just going to take my challenge equation, the equation that I'm trying to prove, and I'm going to replace all this with this. Remember, because I'm assuming that that's true. Okay, so I take this equation, and if I replace the highlighted part with this from my assumption, this equation becomes this equation. Now don't just think, oh, that's kind of neat that it worked out this way in this problem. It's not this problem. They all do this. And just to kind of speak to that a little, we're going to do that with our equation 2. Notice what I'm going to do. Here's my challenge equation. Here's what I'm going to try and prove. Focus in on this highlighted part. Noted that this highlighted part is from my assumption equation. According to my assumption, this whole highlighted part is equal to k divided by k plus 1. So again, I'm going to take my challenge equation, the equation I'm trying to prove, and I'm going to replace this whole beginning part with this. See, so look at my challenge equation. Notice that I've just collapsed the highlighted part to this single term. And then I have my equation simplifies to something smaller. Okay, so now what you would want to do is prove that these equations are true. Once we prove these equations are true, we're done. So let me just recap what we've done. First, we show that the formula worked at some starting point. Then we assume that the formula was true up to some number k. Then we use that assumption to simplify the formula for k plus 1. In plain English, we show that the formula worked at some starting point. Really, that just means that you plug 1 into your formula and show that it works. This is your basis step. You do this for all induction proofs. Next, we assume that the formula was true up to some point k. Basically, we replaced n with k in the formula. And third, what did we do? We used the assumption to simplify the formula for k plus 1. Basically, we replaced the 1 through k part on the left of our challenge equation with a single expression. This is where we make use of the assumption. So that basically summarizes what we've done so far. Notice, but there's one last thing to do. So this is just all the outline of how you prove something by induction. The final part is once you do all of this to get down to your single equation that you're trying to prove, you actually have to prove this equation. Okay, that's step 4. Use your algebraic kung fu to prove that last equation is true. Okay, it's going to take a lot of algebraic jiu-jitsu to show that these equations are true, but we're going to do it in another video. So in the next series of videos, I'm not going to go through the whole hoopla again. I'll just show you how we go about proving that this equation is true algebraically. And then in a separate video, I'll go about showing you how we prove that this equation is true algebraically.